I'm Ethan Kwan, and today I'm going to be showing you what the scale model of the universe is. So I know I've done a scale model of the solar system, but this is the first time of a scale model of the universe, right? So here we go. Scale. Whoa. Hold on. Just get organized here on my desk. So let's try that again. Scale of universe. Whoa, that's bright. Let me just turn down the brightness a little. Okay, so the scale of the universe. Underline it. Okay, so so the scale of the universe. It's gonna turn down there we go. The scale of the universe. So you might know your way around. To start our journey, we're gonna go 5.9091 billion kilometers from our sun to get to Pluto and Charon. And Charon's distance from Pluto is the first thing we're going to start at. So we have, let's say that's Pluto, and this is Charon. Now the reason I've drawn them to approximately close sizes is because technically Charon is a dwarf planet, only that they're kind of orbiting each other. So like this. So they're kind of orbiting each other. Anyway, let me so this distance right here, that distance would be approximately 19,220 kilometers. Now you have to search up in miles, but this is the kilometers, or approximately 1.922 times 10 to the 4th. That's it. Okay. So now we're gonna come way back to 149.6 million kilometers from the sun, or about 150 million kilometers from the sun. We arrive at our home planet Earth. Now we can compare the distance between the moon and the Earth. So maybe that's the moon with Charon from Pluto. So let's say this is, Pluto would be much smaller. Let me zoom in on Pluto. Where's Earth? Aha. There he is. Let me just draw a few continents. Color them in. Maybe a dot for Hawaii. Okay. So Pluto would be about that size, and Charon would be, let's see, what's our scale here? Okay, so compared to here, Charon would be about, let's zoom in, about, let's see, right around here. There we go. Okay, so that's our scale. So as you can see, and this is about, give or take, 20 times larger. So this distance is going to be 184,400 approximately kilometers from Earth, or approximately 1.844 times 10 to the 5 km from Earth. Okay, so if we have that scale, now let's compare that scale. Zoom out a little. Move. Okay, with the Mercury to Mercury versus from the Sun to Earth, and Moon. So the Earth and Moon. Well, let's draw the Mercury distance. So let's say this is the Sun, not to scale, and this is Mercury. You know what? To scale. Now, this distance is, give or take, 57.91 million kilometers. Which is about 5.79 times 10 to the 7th. Approximately 7, not 2. It looks like half of 2. Okay. So that compared with that, I'm guessing right now, but this would be Earth compared to this. So Earth would be about that big. There we go. And the Moon would be, I'll change colors. The Moon would be, let's see, what color should we put the Moon at? Green would be fine. Maybe, give or take, maybe that far apart. Maybe. So remember, this distance right here, wait, is that, yeah, about correct. This distance right here is 57.91 million kilometers. This distance is only 184,000 kilometers. So big difference. Okay, so now let's move on to Mercury. That distance versus Venus. So Sun, Mercury would be about there, and Venus would be, give or take, maybe right here. Now, there is a cool website that'll actually let you scroll like this. Scroll over to actually see the scale of the universe. It's really cool. You should check it out. I'll leave the link in the comments once I finish making this video. Well, once it's uploaded onto my YouTube channel. So this would be, give or take. So this distance. Remember, this distance was 57.91 million. This distance is 108.2 million which is pretty big, but not big enough. So now let's compare it with Earth. So now this would be Mercury, Venus, and Earth would be about there. Because Earth is approximately, give or take, 150 million kilometers. The more approximate number is 149.6 million kilometers, but I'm gonna go with 100, and so I'm gonna go with 150 million. Okay. so now let's draw Mars. Now, I'm pretty sure you're all familiar with this. So, Mars would be about, give or take, let's see, it would be about, give or take, twice the distance from the Earth to the Sun. So, maybe, let's see, what's that distance? This much, go another this much. So maybe about right here. And of course, it isn't drawn to scale. This would be way smaller. But anyway, so this distance is 227.9 million kilometers. Okay, I'm pretty sure you're familiar with all of these, so I'm just gonna skip straight ahead to Jupiter. So Mercury, Venus, Earth, Mars, and Jupiter is about 3 times the length of Mars. So about right here. And this distance is, give or take, 778.5 million kilometers. Okay, let's go further. Okay, so we have Jupiter there. We can make Saturn about maybe two-thirds of what we traveled so far. So maybe like right around here. And this distance is 1.434 billion BKM. We're getting to billions now, folks. Okay, we have a lot of space left here, so it's okay. Let me just zoom out a little. Zoom out on... Okay, anyway, Uranus, it would have, give or take, about twice what we traveled so far. So maybe right around the edge of the screen. So maybe right there. And of course that distance is, drum roll please. Guess I gotta beat my own drum. Can I stop beating my own drum now? Okay, it's my choice. 2.871 billion km. That's not bad. Okay. Let's go to Neptune. And this is about twice what we've gone so far. So, let's see here. So, Neptune is about right here. Okay, so, zoom out a little. You know, the scale of the... You can't even see our planets now. They're less than a pixel. Well, maybe. I think these are already pixels. Anyway, Neptune. That was Neptune, right? These are the inner planets right here. Outer planets. Yep. 4 outer planets. And Pluto. I mean, the Kuiper Belt is a bit closer than Pluto. So, Kuiper Belt would be, give or take, a fifth more away from the sun. So maybe a fifth would be Jupiter. So the sun to Jupiter right now, maybe like that much. This much. So we'll just have to go like this much. Like this. This would be the Kuiper Belt. Give or take. So maybe like this. Okay, now Pluto is about the same distance. Well, technically, it is 5.9091 billion kilometers away, which is give or take maybe like over here. And the Kuiper Belt ends maybe over here at the end of the screen. So obviously we have to zoom out to get to the scale of the universe. Okay. Okay, let's zoom in again. Where's that? There it is. There it is. Okay. So let's try that again. Start off with Pluto. So let's see. The sun would be probably a speck by now. And the Kuiper Belt might be around here. And Pluto might be around here. This is where the Kuiper... Wait, what? What the? What is that? What the? Okay, anyway. Go away. What's happening? Weird. Okay, anyway. Oh, there we go. There we go. It goes away. Okay, so maybe that's the Kuiper Belt. Pluto. Average. That's the average. And the Oort cloud would be, let's see here, approximately 4 and 2/5 away, same as Pluto. So maybe 4 times. So that would be here. That would be 1 time, 2 times, 3 times, and 4 times, and 2/5 of this. So maybe like right here. It's the same distance. Maybe like right here. Okay, so maybe that one. No, maybe like give or take right here. Okay, so gotta zoom out for the Oort cloud. Just for the sake of the Oort cloud. There we go. That's about where the Oort cloud is. Now, of course, Pluto would be microscopic right there. But anyway, you can see it. It's okay. Okay, so now we're getting outside our solar system. Okay? So, Alpha Centauri is about two-thirds away. So maybe like right around here. So that's the Alpha Centauri. Now we have to zoom out it anyway, so zoom in to the sun. Where's that little sign? There it is. So sun, Alpha Centauri. Let's see, we have the nearest black hole. So the nearest black hole, I have no idea how to pronounce this. Maybe Monocerotis or something? I think that's how you say it. I think it's spelled Monocerotis. Did I get that right? I have no idea. Okay, so that's the nearest. Okay. Just my alarm ringing. You know what it is if you've seen my other videos. You know, that's too close. Okay. Like that maybe. And then the next one is about, give or take, 28.382 quadrillion kilometers away. A quadrillion is basically 1 times 10 to the 15th power. So this distance right here is 3.9924 times 10 to the 13. We want to go way farther than that. So maybe the closest black hole would be maybe like a bit more than the end of the sun, right there. Now, of course, this is way farther than anything, so the black hole cannot disturb us. It is about 9 to 13 times the mass of the sun, but it's not enough to harm us. Okay, so now the now the center of our galaxy. So now this would be our nearest black hole. This would be the center of the Milky Way. This would be like that, our spiral disc-shaped Milky Way. Ah, the Milky Way. Disclaimer, this does not contain a bunch of milk bottles. I just wrote milk. Here's the Milky Way. Milk E plus E, way. The way. Way. The milk plus E, way. Okay. Anyway, so the center of the galaxy would be, give or take, maybe not far away. On this distance is 264.9 quadrillion kilometers away. Okay. Time to get rid of all of this and time to switch colors. This color is getting boring. Have you noticed? No, I'm pretty sure it didn't. Perfect. Perfect. Nice color. Okay. So the Andromeda galaxy. So here's all galaxy. Boing. Beep. And here is the other galaxy. Way, not that bigger. Only the supermassive black hole in the middle is bigger, so I'm just going to make that bigger for comparison. So we're about here in the Milky Way right now. And the Milky Way, that to the Milky Way center is, give or take, 24.3 quintillion. Quintillion. For comparison, the Rubik's Cube has 24 quintillion possibilities. 23 quintillion possibilities, I think. So if you just took a Rubik's Cube, that would have 23 quintillion possibilities. Okay, 24.3 quintillion can also be written as 2.64, not this one, not 2.64, 2.428 times 10 to the 19. That's a big number because you're raising something to the 19th power. That's going to be getting really big. 1 times 10 to the 19th, that is 10 10 quintillion, which is pretty big. Okay, anyway. So, now we get to one of the hardest imaginable farther places. So, we have our galaxy, which is now just a speck, and we have MACSO647-GD. That is a galaxy 13.3 billion light years away, or 125.8277 septillion kilometers away. So maybe if we drew it on this, it might be something over... Wait, did I just draw that dot? Yeah, I did. Okay, might be something over here on the other side of the screen. Maybe over here. So, where's our galaxy? You can't even see our galaxy anymore. There it is. Zoom in. Okay, so just make that bigger just to see it. Big, 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 big. That's not big enough. Just to make it big to see it. Big, 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 big. Okay, so that is about approximately the scale. Okay, anyway. Now the edge of the observable universe. So here's our galaxy, here's the other galaxy, and the observable universe is more or less right over here. So this is as far as we can see the observable universe. Okay. I think that's it. Yeah, no. Yes. Okay. See you at howtodostufwithethan.com, and see you next time. Bye. Keep a lookout for the website in the comments. Bye.